Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about environmental chemistry. So, I will talk first definitions. The definition of environmental chemistry is, it is the branch of chemistry which deals with the chemicals and other pollutants in the environment resulting directly and indirectly from human activities. I repeat, it is the branch of chemistry which deals with the chemicals and other pollutants in the environment in resulting directly and indirectly from human activities. Now, component of environment: atmosphere, hydrosphere, lithosphere and biosphere. So, atmosphere. Our surrounding on Earth is called atmosphere. It consists of gases N2O2, CO, helium, neon, krypton, xenon, and water vapors. Its thickness is about 1000 km above the surface of Earth. The gases present in atmosphere are very important in the following ways. These gases absorb harmful radiation of sun to protect life on Earth. N2 is used by nitrogen-fixing bacteria. O2 is required for respiration. CO2 is necessary for photosynthesis. Water vapor are responsible for sustaining life on Earth. Now, layers of atmosphere: troposphere, stratosphere, mesosphere and thermosphere. So, chemistry of troposphere. Troposphere is very close to the surface of Earth in which we live. It extends up to 20 km. It contains all those gases which are present in our atmosphere. This is the troposphere. Now, smoke. It is a combination of smoke and fog. The smoke is of two types: reducing smoke and oxidizing smoke. So, types of smoke: reducing smoke. This smoke contains high content of SO2. It is chemically reducing in nature. For example, the smoke and SO2 produced from burning of coal can combine with fog to create industrial smoke. Now, oxidizing smoke. What is oxidizing smoke? Photochemical smoke is termed as oxidizing smoke, which consists of higher concentration of oxidant like ozone. It is yellowish, brownish, gray haze which is formed in the presence of water droplets and chemical reactions of pollutants in the air. It has unpleasant odor because of its gaseous components. Now, conditions for photochemical smoke. Following conditions are necessary for the chemical process of photochemical smoke: sunlight first, the productions of oxide of nitrogen, NOx, and productions of volatile organic components, VOX, and temperature greater than 18 degrees Celsius. So, NOx, nitric acid, sulfur dioxide converted to sulfuric acid. Now you see the acid rain, acid snow, and lake acidifications. NOx you can see from the vehicles and buzzles, acid rains. This is the from buzzles.com. So acid rain, sulfur dioxide present in it undergoes photolytic and catalytic oxidation to form SO3. Which reacts with rainy water or moisture to form sulfuric acid. You can see NO2 react with rainy water in the presence of O2, NO3 and produce nitric acid. So, carbon dioxide react with the rainwater to form carbonic acid. So, sulfuric acid, nitric acid, carbonic acid. In some countries, HCl is released by the volcanic eruptions. So, these acid formed as above come down in atmosphere as acid rain of acid snow. Now, impact of acid rain. It makes lakes so acidic that they can no longer support fish life. The yield of the agriculture crop is also reduced. Nitric acid rain gradually eats up limestone and marble of buildings and corrodes metals. It fades the color of the fabrics, cotton, nylon, and rayon, leathers and paper. Causes extensive leaf drops in plants. It is very corrosive and attacks skin. It is the acidification of soil and rocks can leach metals like aluminum, mercury, lead, and calcium and discharge them into water bodies. Then these heavy metals are eaten by fishes, which proves very much dangerous for those animals and birds which eats these flashes. It also damages steel paints, plastics, cements, masonry work and sculpture materials. Now greenhouse effects. You know the heat causes the atoms in the Earth's surface to vibrate that radiates heat and infrared radiation. CO2 and water vapor in air by absorbing infrared radiation act as insulating layer to prevent heat from escaping. These often referred to as greenhouse effects. No, my friend, the trapping of the heat on the surface of Earth by carbon dioxide and water vapor in the atmosphere is known as greenhouse effects. Look at here, short wavelength atmosphere, long wavelength, CO2 and other gases in the atmosphere trap heat, keeping the Earth warm. Global warming. The concentration of CO2 in the atmosphere is about 330 ppm, but it is known to be increasing. When level of CO2 increase up to 400 ppm, temperature should rise as much as 1 degree Celsius. The mean global temperature at Earth's surface is about 15 degrees Celsius. Any change in amount of energy absorbed or emitted by Earth could affect our climate. The average global temperature and concentration of CO2 have fluctuates on a cycle of hundreds of thousands of years as Earth's position relative to the Sun has varied. As a result, ice ages have come and gone. Volcanic eruptions emit particles that cool down Earth's surface temporarily. Even nitrocycles also have temporary effects. CO2 levels have increased by more than a third since the Industrial Revolutions. So climate change are now occurring rapidly. 11 of the 12 hottest years are between 1995 to 2006. So automobiles, pollutants and converters. You know automobiles engines use hydrocarbons fuels. Fuels have general formula carbon hydrogen, so called octanes. The incomplete burning of fuel release carbon particles CO, CO2, water vapors. At high temperature N2 and O2 combine to form NO and NO2. So carbon particles CO, NO, NO2 all are pollutants. So production of pollutants. The pollutants produced in the internal combustion engine by the use of petrol are CO, NO, NO2. By incomplete combustion of petrol, some CO, unburned carbon particles, CO2, water vapor, some alcohols and acid are produced. When petrol burns in car engine, a very high temperature is produced. At this temperature, N2 and O2 in the air of the engine combine together to form NO and NO2. So control measurements. You know, use of PB tetraacetate or TEL reduces rate of combustion, complete combustion, reduces evolution of carbon particles and CO. Catalytic convert attached to vehicle's engine contains platinum-based catalyst, catalytically complete combustions of carbon particles and CO. You can see the octane react with O2 form carbon dioxide and water, and carbon monoxide react with O2 to give carbon dioxide. Three-way catalyst you can see in this pictorial diagram. CH, CO and NOx and N2, H2O and CO2. So chemistry of a stratosphere. Stratosphere is present 20 to 40 km above the surface of Earth. Ozone is present at the height of 28 km and the concentration of ozone in atmosphere is 10 ppm. You can look at here. So production of O3 and its oxidized toxic effect. Some O3 is produced during the combustion taking place in air. O3 concentration more than 0.1 ppm is toxic and harmful for human being. O3 also attacks rubber. So it is produced in the upper part of the atmosphere by action of sunlight on O2. Look at this reaction. Now protective action of O3 layer. Thickest layer of ozone is at height of 23 km from the surface of Earth. Ozone in this layer absorbs harmful radiations combining from the sun. If ozone layer is in the atmosphere disappear completely, then all the harmful UV radiations coming from the sun would reach the earth and would cause skin cancer in men and animals, and we will damage the plants. So sources of destruction of O3 layer. Oxide of nitrogen decompose O3 into O2 and themselves degenerated. And these oxide destroy about 70% of O3 found in the stratosphere. Greater the amount of oxide in the atmosphere, greater is the percentage of O3 which is destroyed. So nuclear test being conducted in the world generated high temperature. At high temperature, atmosphere nitrogen is favorable oxidized to NO, thus thus form destroy ozone layer. So chlorofluorocarbon are the chlorofluoromethane like freon, chlorofluorocarbon and freon difluorodichlorocarbon. These are used as aerosols, spray, propellants, refrigerants, firefighting reagents, and solvent for cleaning electronic components. When they enter stratosphere, they absorb UV solar radiations and get broken down into free atomic chlorine, and this atomic chlorine decompose O3 into O3, O2 to O2. So how to protect the ozone layer? This is last topic, and then I will prepare next video on the basis of environmental chemistry. In order to save the ozone layer, the use of oxide of nitrogen and chlorofluorocarbon should be banned, or some new types of substance should be discovered which may be used as aerosols, spray pollutant, and should not react with O3 layer, so it may be saved. So alternatives to chlorofluorocarbons I will discuss from here in the next video. So if you like such type of video, then subscribe my channel, and thanks for watching.